So my name is Chris Packham, University of Texas, San Antonio, and also I hang out in Japan a little bit. And this is a talk that I put together with Bernard Brandl, who's over in Leiden and Delft. So thank you for your help, Bernard. This has been, you've been invaluable in helping to put this together. So, but before I start, I really would like to say a big thanks and a big kudos to our SOC chairs, Leo and Valentin, for pulling this together. This has been quite an adventurous meeting to pull together. So thank you so much for doing this. Really impressed with the meeting. I'm loving the Zoom, Slack, and Gather things. And also, it's really nice to see my long-term colleagues, friends, and some new friends. Even if you're only in the Zoom box, it's really nice to see everybody again. So thank you again to everybody. So originally, I had planned to present about MICHI, the thermal infrared camera that we're proposing to put onto the TMT. But after thinking about it and talking to Bernard, we thought it might be useful and perhaps more interesting at this general thermal infrared meeting to present the results of a survey that we conducted rather than simply another update on MICHI. The reason is really twofold. Firstly, I presented MICHI in many other venues. I'm happy to provide any notes, any papers, any information. Please feel free to send me an email, send me a Slack message. I'll provide you with more information than you care to have. The other thing is TMT is not in the construction phase at this point. It's in a phase of trying to understand the site and is waiting for the USA's decadal survey. So instead, we thought, well, let's engage with the hive mind and try to understand how we can feed back some information from some people who have been pretty closely associated with the thermal infrared instruments and try to think about how we can offer help and advice to people planning new thermal infrared instruments and indeed to the people who are thinking of hosting those instruments. So you saw this table before. It's been discussed on Slack at all. This was the table that Bernard dominantly put together. I maybe helped fractionally on this, but we made a partial census of thermal infrared instruments on 4 meter or above, or approximately 4 meter and above. And we contacted the PI as far as we could find their email address and or the instrument scientist for that instrument. As you can see on the right side, this is the improved version. So thanks to everybody within this group for helping us to improve that. So we contacted 21 people. We got 13 responses. Some people PI'd more than one instrument. So this does represent more than just kind of 13 instruments here. The people who responded very kindly allowed me to acknowledge them. So thank you to all of these people. I have augmented or even embellished, some might say, some of these comments by myself. Bernard has provided some comments. I think I will note here the total lack of gender balance within this group. I'll just quickly note this and comment that in this discussion, with Leo, as we were pulling this together and talking about instrumentation, that's one of the reasons why Leo felt very keen to have the diversity and inclusion discussion. So I just want to pay homage to Leo for seeing that and encouraging that session yesterday. That was a very important thing. So the survey questions are here. I'm not going to bother to read these out. These are just going to be archived. So if you're interested in what we ask people, please feel free to see these slides or the video of this later. And what I'm not going to do is run through each answer. That's boring. It's too dry. Instead, we collated the answers and tried to look for common threads between the answers that we could clearly identify. And we saw 8 themes that the various instrument teams and the various respondees commented back to us. So these are the 8 areas that I'm going to be running through for the rest of this talk. And I'm not going to read out every point again. Again, this will be archived and you can read the responses. I don't attribute instruments unless it's a positive comment or observatories, again, unless it's a positive comment. So you can go through the details there, but I am going to go through the things that I highlight either in red or highlight in yellow. So the first is communication. And that's both internal to the group, to the instrumentation team, as well as between the instrumentation team and the observatory. So the first comment, I'll start with the positive stuff. Michelle and Yuka really because of the close relationship between the telescope group in Hilo and the build team in Edinburgh, was integrated, operated, and performed extremely well, almost pretty much out the box. Miriam James Webb, I love this comment here. It's been a triumph of primarily European collaboration, primarily because of the professional but pragmatic project management team. Matisse, what went right? The consortium, ESO, in this collaborative spirit. But something that didn't go quite so well is when the telescope and build team relationship was not maintained after delivery, and then that led to the instrument being neglected and underused, at least in the view of the person who responded to me there. A very common thread, and I think something that will resonate with a huge amount of pain to many of us who have been near these mid-infrared detectors, is detectors really are tough. I like this comment here, difficult things, whole laundry things, but the second most important was detector performance. And there was a comment here, advice to help make things better, buy and characterize the detectors first. That's a nice idea. There's some other comments very specific to ESO here. But I think what's clear is the detector stability, the detector noise, very much drives the chopping. Of course, we have to worry about quantum efficiency and other aspects, but the stability and noise drives the chopping, which is one of the other areas that people were very concerned about and experienced a lot of pain through. So with the chopping, it's really important to ensure that the telescope is designed to chop efficiently and effectively. And chopping is one of the most limiting things for the 8 meters. Make it efficient, have tip-tilt guidance, tip-tilt correction, and without ringing, meaning when you get to a position, no chop tails or no ringing, no vibrations once it's got to the chop A or chop B beam. And indeed, this, I think, we've heard from several, was a major limiting factor for the 8 meters. And certainly some of the instruments that I was involved with, this was an area of pretty significant pain. From myself, I just added this slide in, as the 30 meters are simply too big to chop the secondary mirror or tertiary or whatever number the mirror is on the ELT, pupil plane choppings will be incorporated for the planned thermal infrared instruments, at least the mid-infrared instruments. So hopefully that will eliminate the problems associated with that chopping mirror. But of course, it could make a whole host of new problems, but let's hope it doesn't. Let's hope that we get away from these chopping issues with that. Data reduction, and I'm going to ask Leo to launch a poll in a moment. So one of the comments that I thought was insightful was that the operations and data flow down to science-grade data products should be as close as possible to those of the standards of optical instruments or indeed space-based observatories. So Leo, when you're ready to launch the poll, please go ahead. I've got 2 questions here that would be helpful to get a feedback from. I think both Bernard and I would welcome the results, so please do take that poll. So I'll read out the question 1. Making a fancy pipeline, an advanced pipeline, takes a lot of effort. How do you wish to reduce your data for publication? And please choose one of those options. But of course, nothing comes for free. A full pipeline for a 2nd generation VLT instrument would be in the ballpark of about 20 FTEs, so it's pretty expensive. And then the second part is this true for all modes or just complex modes? So I'm going to hold on for a little bit longer. I'm seeing that there's about 20 people responded, so I'll wait for about another 20 seconds and then ask Leo to close the poll and share the results. Okay, Leo, let's go for about another 5 seconds. 4, 3, 2, 1. Okay, Leo, would you like to close the poll? And I think you can share the results, as perhaps people would be interested to see that. Oh, gosh, I guess you can see the results on my screen anyway, right? So there's the results. Sorry, I forgot that it was being shared there. So thank you very much. That's very useful. So people slightly prefer option 2, although option 3 for the final data products was there, and pretty conclusive view that this would be true for all the modes. So thank you very much for those comments. So if I can get rid of this. Okay, so reviews. As building instruments, as people building instruments know, we all enjoy reviews. I found 3 comments very interesting here. So the first was, none of the issues we finally had to solve had been spotted in the design reviews, even though in hindsight some were quite obvious, and frankly that wasn't me who wrote that, but that resonates with me, that comment. During the assembly, integration, and test phase, the instrument was plagued by substantial electrical problems, which were due to a concatenation of design errors. And I love this third comment. Reviews are not for ESO, or we could generalize that, not for the observatory that's going to host it. They're for the instrument team to close loops, write the documents, reflect, and get together and think about things. I thought that was an interesting and useful comment. Observatory contact. So let's deal with the good stuff first. So firstly, get an observatory person to work with the instrument development, especially for anything on an ELT. This will greatly help in the handover of the instrument to the observatory. Embedding observatory staff within the instrument team is key to aiding communications and the rollout of the instrument. I very, very strongly agree with that comment. And finally, you've got to really engender the spirit of collaboration between the observatory and the instrumentation team. Firmly agree with that. I love this comment. Someone was a huge fan of the IRTF. The IRTF provided all the support we needed, but let us run things the way we wanted to. Sounds like a dream scenario. So clearly we all want to go to the IRTF nowadays. And I'll leave these other ones for the archives there. The observatory contact, bad. Because the telescope observatory was being built in parallel, it was very hard to get interface information from the observatory, which turned out to be one of the biggest overheads for the development. And yeah, that's, I've been involved in 2 observatories that were building instruments whilst the observatory was being constructed, and certainly one of them suffered from that comment more than the other, I think I can say. And as we think about the 30-meter telescope and the ELT and GMT, presumably the thermal infrared instruments will be dealing with this issue as well. So I thought that was an interesting thing to note. The good side, we were able to develop a relationship of mutual respect and shared goals. This was challenging but vital, but for the other instrument, this was not the case, and the telescope instrument interface was a disaster. I'm not going to read out these ones in black here, but I will just highlight this last one, which I have no comment on. It's not me. They made up their own reading of the contract. Whoever wrote that, you have my sympathies. I don't know what to say on that one. Thermal infrared as a niche area. We asked, what do people think about thermal infrared being a niche area and how to expand the community? And indeed, we've got a discussion panel that perhaps can touch on this tomorrow. So the first set of comments relate to data reduction again. The observation technique is not simple. We need more steps for the data reduction than standard. There's not enough support for the data reduction process. And I think a lot of us can have sympathy with that. One comment is, could the answer simply be that the kind of exciting area of research that people want to do is just out of reach from the ground? Of course, the ELTs will change this because the high angular resolution and the sensitivity that we'll give compared to the 8 to 10 meters, but perhaps it was just too tough to do this from the ground, from the 8 meters, other areas and sensitivity there. I'll read this one out completely, although I'm not sure I agree with the first part. No direct to mainstream astronomy. I think that's, we can agree to disagree on that one. This comment, results need to be marketed more aggressively. That's an interesting comment. Maybe more of those wonderful Sophia Hawk Plus pictures that Enrique is producing with the polarimetry. Keep the number of observing modes as small as possible and then steadily upgrade in the future. That's easy to, and perhaps this is easier to do with a compact, well-aligned community, so the community can give a greater feedback rather than a huge community, perhaps in the optical or the near infrared. So perhaps in this case, niche is not so much of a problem at all. And I will skip past these last two. We asked if people were generally happy with the scientific return from the instrument, and fractionally over 50% were generally satisfied. I don't know what this graph would look like at other wavelengths or other observatories, so I have no way to put this in context, but I found this interesting that was only 57% and not much higher. Advice regarding the 30 meters. So don't make the mistake to scale efforts and support by the size of the community. I'm sure we'll all resonate with that comment. Be aware of the potential of the thermal infrared and indeed the limitations. Simpler, less challenging designs will hopefully make a more rapid science delivery. And perhaps a corollary to that is decide which operating modes are essential, get them working quickly so that early science is delivered and successful. Clearly, and I think we heard this a lot, and Bernard presented this in his Metis presentation about the high spatial and high spectral resolution. But on the observatory side, it's really important that the telescope is capable of diffraction limited performance in the mid-infrared with a tip-tilt secondary, or perhaps with an AO system on the TMT, and perhaps on the TMT side of things. One comment I liked here: chances are that thermal infrared instruments will be the first ones to work at or close to the diffraction limit, so that could be an impetus to get these thermal infrared instruments on the telescopes as soon as possible. But this next comment, I'm going to read this in verbatim. It's a long comment, but I thought this was potentially a useful thing to discuss as the group here. So the suite of instruments for a 30-meter class telescope has to be viewed differently than how one would consider the suite of instruments on an 8 or 10-meter telescope. The TMT had an initial plan of accommodating 12 or so instruments. I now think that an ELT should have a maximum of perhaps 3 or 4 instruments at any one time, so that each instrument has more time on sky during its lifetime. When instruments cost more than $30 or $50 million, you wanted to have as much time on sky as possible and to decommission when the main objectives are achieved. Then let another instrument have a chance on the telescope. So I think this requires a change in thinking about the observatory instruments for such a large telescope. I found that an interesting comment. And perhaps this is in contradiction in some ways to the previous comments, which said simpler and less challenging. If we're only going to have a small number of instruments, then one would expect that we would have an instrument that can do many types of things to serve a broad community. So this was interesting that we are getting this dichotomy between the instrument builders of the past, instrument scientists of the past, and present. Sorry, they're still here. So conclusions and an invitation to discussion is, I found it interesting that communication, both internal and to the observatory, remains crucial. Embedding observatory staff within the instrument team is key to aiding communications and the rollout. And my own comment is, it's kind of amazing to me that despite all of our 21st century communication tools, seemingly continuous lessons learned meetings, if we ever go to SPA or any other instrumentation groups, we always have a lessons learned. It's amazing that communication is still the foundational point. I guess humans are just humans. Detectors and chopping have been major pacing items. GeoSnap is of great interest to many, and I think there's a presentation on this on the last day. So I'm looking forward to hearing that presentation about some of the characterization going on there. Better data reductions could help to broaden the community and reduce the difficulties in reducing and then interpreting the data. Reviews are most important for the team to pull the documents together. And again, this dichotomy about making the instrument simple or serving a very large community if there's a smaller number of instruments on the 30 meters. And finally, the thermal infrared might be the first to reach a diffraction limit on the 30 meters and can well exploit the high spatial and spectral resolution. And with that, let me open it to questions or discussion. So back over to you, William, as the chair.
Thanks, Chris. I would suggest, given the level of discussion and point of views that we can exchange here, to do this vocally and not through Slack, because I don't think writing down your opinion will contribute to a quick turnaround of ideas. So I would like to give the word to the biggest comment so far. That was by Jim de Boiser. Jim, would you like to express your view here?
I think my microphone's working now. Can you hear me?
We can hear you fine, Jim.
We can.
Yeah. So I was surprised at the when we took the little poll there about data reduced products in the mid-IR. You put a number of about 20 FTEs, which is to me it looks like a surprisingly large number, given that we don't have anywhere near that many people working on the pipeline for SOFIA, the full pipeline for all the instruments. But anyway, I just wanted to say, SOFIA does work much more like a ground-based observatory in the mid-infrared than a space-based observatory. We do have to chop, we do have to nod, we do in the spectra have to do caloric corrections and things like that. So a lot of inroads have already been made in putting together a pipeline to sort of automatically reduce mid-infrared imaging and spectroscopic data. This could be leveraged by other observatories rather than having to start from whole cloth. And I think you'd be able to do it with a lot less than 20 FTEs if there was some cooperation that went around. We can learn off each other and integrate the pipeline, which would be a good thing as well. But I think one of the great things about SOFIA is people can just go to the archive and get science-ready data, and I think that is a bulk. That is a point where people bulk if they're outside of the mid-infrared, if they're looking for Vizier data, or looking in the archive for old T-Rex or Michelle data or something like that. There's this hurdle to get over, and not a lot of people know how to get over that hurdle, especially if it's an old instrument that's been decommissioned.
I agree with everything you say, Jim. Thanks.
Any takers on this particular topic of pipeline investments? Enrique, could you express your view that you put on Slack?
Oh, yeah, I think it's aligned with what Jim was saying, but also in terms of like if the instrument team has already developed a pipeline that produce maybe not a science ready, but almost close to science ready, and that pipeline is open and accessible to the community, where the community can access and refine it and optimize the pipeline, and everyone, like AstroPy, for example, something in that kind of idea, where the community can access and improve it, would be great to have it. And also it's transparent for the people, because sometimes you read papers and they use their own data traduction. You don't know exactly what they do, and another team can work in completely different way and sometimes get a different results. So that make the final data for a very complex instrument more transparent for the scientific output, which at the end of the day, you need to compete with other instruments and make the infrared window more attractive to people who do radio or UV or other wavelengths.
Yeah, again, Enrique, I agree with your comments there again.
Mm-hmm.
Yeah.
Thanks, Enrique. Alain, would you care to comment?
Yes, I would like just to point out that it takes quite a lot of time and a lot of effort by many people, in particular also in the data reduction, to really understand a proper a mode and an instrument setup. And I'm really afraid when I see the instruments on the ELT, the large number of modes, the large number of setups, made that I really wonder if we will have the time to properly characterize them.
I don't have any comments on that, Alan. Yeah, but I think it's a concern of how long and this dichotomy. I thought that was interesting, that dichotomy of do you want to keep a large number of kind of simple instruments or very large instruments that are highly complex that can feed a very large community. I found that interesting from this survey.
Can I give the word? Yes.
Can I try to answer Alain's question, because it seems to me that the answer is no. Simply because, because of the complexity. You commission an instrument, you provide you show that it's calibrated, but that's far from providing a general calibration for the pipeline that is foolproof and really provides archives that can be used by people, easily used by people who have not been involved in the observations. So I guess if someone wants to go back and re-reduce data 5 years later because he or she thinks she can do a better job than the original proposers, I think you start from the raw data anyway, and it's a non-issue. But what we've been doing for Spitzer, for example, is so you have all these observations of starburst galaxies or ULURCs. I can imagine that after 10 years of ELT, TMT, whatever operations, you also have an archive of HEN, for instance. And you would like to have sort of a tool to search through the archive and compare the data. And of course, if you have to do your final tweaks of calibrations, that's almost impossible. But I think these big surveys, a lot of science is there if you have more than one or your program target to look at. And this will only work if there is significant pressure from the community that the observatories will actually allocate sufficient resources to do that, because the instrument teams deliver the instrument and it's not part of the agreement to have years of support of the pipeline, which is probably important and necessary to get to that point.
But if I can make the point, Bernard, you basically just say that it would be actually much better to have a small number of setups which can be monitored over long observations than the large number of setups or modes where you don't have necessarily a large database to properly characterize.
Well, no one wants to give up flexibility, right? Never. But the fact, in the case of Spitzer, which is for an infrared satellite, it's so easy to use like Hubble, right? You always get the same quality of data and there are no moving parts. There's not much you can do wrong. You always have the same setting, and people hated it in the beginning to some extent because you're forced to do things in a certain way, and it would be maybe smarter, better, more efficient to do in a different way. But in retrospective, of course, the limitation of flexibility helps in providing uniform data sets.
Yeah. Pat, would you like to comment on this?
I can do.
I mean, I saw your remark.
Yeah.
Yes, please.
Yeah, I mean, the worst outcome is to have a flexible instrument that no one can exploit properly because it hasn't been characterized. And so somehow you've got to get a sort of balance between ultimate performance and usability. And I think a particular issue for the mid-infrared is that in order to really characterize an instrument, you need very good observing conditions. You know, small bits of cloud, you know, really do a lot of damage. And so finding an observatory that's willing to invest the time to characterize a large number of modes is quite a challenge.
Yes, I agree with that. Any other takers on this topic? I mean, and at ESO, I mean, we can see that we have already problems nowadays. I mean, of course, we have many more modes and instruments that we need to take care of, the pipelines in particular that we need to take care of. But the overhead or the investment and the resources that it takes is huge. And well, part of the work that we do depends, so within the observatory depends strongly on what kind of pipelines we have. All the quality control that we do at nighttime depends on the pipelines, and the pipelines need to be developed in order to be able to produce data of sufficient quality. There is already a major investment, and there are enough examples for which we did not have that pipeline and could not assess the data. And given that the data tends to become more complex with the years, pipelines are indispensable.
Mm-hmm.
Even for the simple observatory work that we do, let alone for the user community. Let's see, there's another remark by Jim. Would you like to, you have a proposal of hybridizing data reduction. What do you mean with that?
Well, I was just listening to what people were saying, and you know, we all observatories have the same thing. You know, do you keep yourself flexible and make yourself available to do all different types of innovative types of observations, or do you close yourself down and say, okay, let's just stick with the few modes that are most popular and we can easily calibrate, and that's it, and make things easier and more efficient in that way. But there is a, you know, there's a step in between where you can offer fully or almost fully reduced science-ready data for those modes that are the most easily calibratable and are the most popular, while still allowing the flexibility for less used types of modes or techniques, with just the caveat that they're not going to have as well-reduced data. You know, that's the other way of going about it. It doesn't have to be completely one or the other. And I also just,
before
Enrique brought up the point about you know, doing things in sort of like a Python, like a Jupyter space or something like that. And I think, I don't know if anybody is online who is familiar with Gemini, but there was a while there that I think Gemini tried to take their tools and make them publicly available online and open up like sort of a forum for people to do basically what Enrique was talking about. And I don't know how successful that was. I remember I looked at it shortly after the launching, and I didn't see a lot of activity there. And I don't know necessarily how successful it is, how successful it was. If it was successful, that might be a place where these, you know, sort of unique modes would go to have some sort of support. You know, they could have their data less reduced, but you'd have this support structure in a Slack-like environment, I guess. You know, I don't know if anybody from Gemini is familiar with what I'm talking about or has any input.
Is there any? Please speak up. I cannot see hands raised. Oh, Nancy, please.
So Jim, I'll speak up only to declare my ignorance that was this is Nancy. That was something that was launched, and then I lost track of it as I left Gemini soon thereafter. I think though since then there has been much stronger development of AstroPi and some of the other open source software communities. And so there may be some better opportunities there, especially as some of the space observatories too, and I put Webb firmly in there, are using some of those open source opportunities, so that you get to take advantage of the big agency investments to make sure that something is developed while putting it in the open source environment where other people can modify and contribute.
I can jump in there. I think that the combination of Amazon Web Services, where you can have a pipeline running in a server, which is very cheap, and then having a GitHub repository where the people can go and modify the pipeline in a transparent way with a different expertise. I think this is where the people and the community is going forward now.
Yeah, I'll just add one thing that Enrique had mentioned is those kinds of platforms and notebooks are actually reducing a huge amount of what had previously been overhead and incompatibility as different people tried to work on code.